welcome to Arnav. Today is the 37th episode in the space series. So today we are going to discuss about the types of orbits of satellites. Not planets or stars, it is just satellites. So about how the satellites in space go around. Satellites doesn't mean moons. Satellites means artificial satellites made by humans, like the GPS satellites or the ISS. Those satellites. So when rockets launch our satellites, they put them into orbit in space. Yes. So their gravity keeps the satellite on its required orbits. So for different uses, we have many different types of orbits. Yes. So let's start with the first geostationary orbit. So first, let's take the Earth. So this is the Earth, remember that. Okay. So from about 35,786 kilometers from the Earth's surface, there will be the GEO orbit or the geostationary orbit. So think of this as the 35,000 kilometers away from the Earth. So the main use for these satellites is so let's take a satellite here. So first the use. So the use of these satellites is mainly for communication satellites. So you may think, how does the phone from here to another country come? It is mainly because these satellites, or how a message comes from one place to another place in the opposite side of the world. It is because these satellites only. So there are many of these satellites. So their main use is to just tell people what is right. So they can see lot of things from there. That's why they are from. So here cell towers send messages to here. Then so this satellite will again send those messages to another place where another satellite sees it, and again that thing will happen until it reaches the another place. Yes. So those are the geostationary orbit. So yeah, okay. And also these will follow the Earth's orbit. So for example, let's take this globe. Yes. So it will go around the equator. Unlike everywhere it wishes to, it just goes around the equator. Yes. So from west to east. So it perfectly goes at the speed which the Earth rotates, which is 3 kilometers per second. That is a very fast speed. Yes. So with that speed, it will see the same side every time. That communication satellite will see the same side every day, every moment, every year. It will see this side only. It won't see this side ever. Yes. So that's why it has stationary, because from this view it is just stationary. For example, we are just here. So if we see that every day, it will be just there. That satellite will every be there. So next is the low Earth orbit. So these are orbits below 1,000 kilometers. So okay. So think of this as just 1,000 kilometers. So low Earth orbits. So satellites in low Earth orbits are just used for remote sensing things. So yeah. So this low Earth orbit stretches from 160 kilometers to 1,000 kilometers high in the atmosphere. Yes. So these satellites, as said before, are mostly remote sensing satellites or have other uses for human life. Yes. So unlike these geostationary orbits, low orbit satellites can go anywhere, everywhere they want to at any speed. And also another fact, these low Earth orbits go at the speed of 7.5 kilometers per second, which makes them go around the Earth 16 times per day. Yes. Okay. So So next, the medium Earth orbit or the MEO. So this is between the orbit of the GEO and the LEO. So any orbit over in this general area will be an MEO orbit in space. So orbits here are also similar to the lower orbits. I mean the satellites here. So here there are remote sensing satellites, and also there will be some GPS satellites also. Yes, GPS. So all the GPS satellites are in the medium Earth orbits also. Yes. So next, the polar orbit and the sun synchronous orbit. Yes. So think of these as the poles of the Earth. Okay. So polar orbits are just normal low Earth orbits, but instead of going like anywhere they wish to, these orbits go from north to south of the Earth, like that, similar to that. Yes. So they also have the same use of the low Earth orbits, which is just to remote sensing satellites. Yes, same use. So next, sun synchronous orbits or the SSO. So sun synchronous orbits are also a type of polar orbits. So these orbits will follow how the sun goes. So there's a place on Earth. So if this satellite goes over it at, for example, 12 a.m. every day, I mean let's take 12 p.m. every day, then the next day it will also go at 12 p.m. and for every day it will go to the place at the exact same time and minute. Yes. So these satellites use is to take a picture of the same place at the same time. Yes, instead of different times. It may be midnight or midday, but here it just takes the same time in the sun synchronous orbit. Next is the transfer orbit and the geostationary transfer orbit. So these two are related orbits. Yes. To show we need to have a bit more space, so we are going to erase this. Okay. So let's draw a new Earth. Okay. So that is the Earth. So first is the transfer orbits. So transfer orbits are type of orbits which sends a satellite into outer space. Instead of just around the Earth, it sends those satellites into other planets' orbits or around the sun's orbit. So first, for example, the place which the satellite started was here. So it will start from down. Next, it will take the transfer orbit. So first, this transfer orbit is like an oval shape. So its longest most point or the farthermost point from the Earth will be exactly 35,786 kilometers, or it meets the geostationary orbit. So after it does one orbit, next it will turn into a GTO orbit or the geostationary transfer orbit. So it is not related to geostationary, but the only relation between them is it is at the exact same distance from the Earth, which is 35,786 kilometers. Yes. And so from here, finally so that rocket sends the satellite into outer space where it can go around other different planets. Yes. And last and finally are Lagrange points. So Lagrange point technically is not a type of orbit. These are just points in space. So far, we need to draw the sun and the Earth for this. This is the sun. Next, this is the Earth. Here, the orbit is not that close, but there's no place. So, up to now, there are 5 Lagrange points.
What are these?
So, first, what is the use of Lagrange points? So, first, our Earth produces a bit of light. So some satellites see from telescopes, right? Some satellites are telescopes. So if they want to see other galaxies, the light from Earth blocks those light. So blocks the stars. So if those satellites are very far from Earth, then they can see those stars. But if they are very far, like millions of kilometers, like the Lagrange point, they will not contact the Earth, or it doesn't have any relation between Earth. So in these points perfectly, their satellites have gravitational relations between the Sun and the Earth, the both of them. So up to now, as I said, there are 5 Lagrange points, right? So the first Lagrange point is just in front of the Earth here. Yes.
1.
So this is L1. Yes. Next, the next Lagrange point is just behind the Earth, which is L2. Next, on the opposite side of the Sun, there is the L3 point. Next, on the back side of the Earth's orbit, on the front side of the Earth orbit will be L4, and finally at the back would be L5. So these are Lagrange points. From here, that view of those telescopes or satellites is very clear. Yes. So this is for today about the types of orbits. Bye.